How about using AI assistants to create microtools instead of replacing engineers? This is one idea that Simon Wardley, the creator of Wordly Maps, has come up with, and let's look into it. Welcome back to Think Design Work Smart. I'm Alex Bolboaca and I'm coming at you from the Mosaic Works studios. And today we will discuss this LinkedIn post by Simon Wardley. This is older blog post, LinkedIn post is 3 weeks old at the moment of writing, but it's still very, very interesting. And before we move on, Simon Wardley is the creator of the so-called Wordly Maps. These are tools or a tool used for mapping the landscape and creating strategic plans and strategic scenarios. It's a very interesting idea, one that it's definitely useful for anyone interested in strategy. And in particular, from my point of view, what's interesting is technical strategy. So we can definitely use Wordly Maps to look into technical strategy as well. So let's go first through this LinkedIn post, and I will stop and give you some thoughts and comments and ideas. But the main idea here is that maybe we are thinking about using AI assistants in the wrong way. Software engineering is a decision-making process, and as with all such processes, we have to start with an assessment of choices. That requires exploration of the options and some form of conversation, either with the person or the machine. That conversation needs information which has to be synthesized somehow, which in turn requires a development experience based upon the system in question. So this is a very general and quite abstract model. But let me point out a few things. First, he's talking about problem solving rather than, or problem solving in the context of development. It's more about software engineering. So for me, a simple definition of software engineering would be solving problems sometimes with the help of software, of programming. But the main and most important part is solving problems. And the way we do this is through an incremental process, or through another way you can think about it is knowledge refinement. So what Simon is talking about is a series of decisions, a decision-making process. So you make different decisions and you end up with a final result. Another way to put it is to think that in the beginning we have raw knowledge. We have some needs, some wants, maybe a problem description that needs to be refined. And at the end, we need very refined knowledge in the form of executable code, which is the most refined way of writing knowledge, because it needs to be executed by a computer, and computers are pretty silly. So this is where we are discussing. That's the range of the options. Too often we focus on one thing and say, let's use AI assistants for generating tests or for generating code, and that's not the point. What we should look at is the whole process, the whole problem-solving software engineering process. To give an example, let us take testing as in test-driven development. We start with a hypothesis that the system lacks this feature and we build the test to check for this. Yeah, so very good approach to test-driven development. This is what it's about. It's hypothesis-driven. It's the same of product discovery, hypothesis-driven. If you go far enough and you understand well enough product development, you understand that you don't have features, you have hypotheses. And so if you look at product development as a whole, you start with a hypothesis, you test that hypothesis, sometimes by implementing features, right? But what you have are hypotheses, and an example of hypothesis would be 10,000 users who will want to use our application if we offer export to CSV, whatever. And then you test that hypothesis in various ways and sometimes by implementing code. The next level of this is, well, architecture and so on, but when you go to development, the hypothesis is this feature does not exist. So I'm writing a test and I'm testing that hypothesis. What happens if the test passes? Well, the feature exists, so nothing to do, right? And we move on to the next feature. Now, of course, what's important here is that these tests should be very small. So that's another important thing, because going back to engineering, engineering is about incremental decisions often. You need to split a big problem into small problems, and each small problem to solve each small problem, well, to explore and then to solve. And sometimes you need higher level exploration as well. Okay. So we start with a hypothesis that the system likes this feature, and we build a test to check for this. That test is part of a systematic mechanism of exploring the space, which is what TDD is, using a model created by the tests. If you've ever heard someone say the best specification is the test suite, then this is what they mean. The tests model the system. The output information of those tests are traffic lights synthesized from specific coding. The overall experience is one composed of thousands of small micro tests, the test suite. Software testing is very firmly an engineering practice. Well, this type of software testing, because I have seen other types. I worked with a team once where analysts didn't know very well what they were analyzing, developers didn't know very well what they were developing, and testers would introduce data, then look at the output and say, yeah, looks kind of okay. So it's true, I hope you haven't seen that. That was a nightmare scenario. So I hope that that's not the case for most organizations, although it might be the case for LLMs, since we are at it. But yeah, if you do software testing in this way, absolutely. It's an engineering practice, it's repeatable, it's incremental, it solves a problem. Of course, once we run our test and see it fails, we switch to development in order to fix the problem. We grab our monolithic coding environment, which we use for every problem. We inspect the code, often through reading, and we manually gather information to explain the problem, from architectural diagrams to logs. We like this because we want to be data-centric. But then most of those diagrams are actually statements of belief rather than fact. Very important part. One issue with diagrams, comments, is that they tend to get, and other forms of documentation, is that they can tend to get away from the code. It requires discipline to maintain the documentation and the code in sync. And if you don't have that discipline, or if sometimes you hurry, then it's likely that your documentation does not fit the code anymore, which is why one of the core ideas I try to teach developers when I'm working, particularly on legacy systems, but not only, is in code we trust. The code contains the reality, the truth of the system. Now, that truth is sometimes hidden because you cannot in code express higher level concepts as well. although maybe we should try. But often there are details that are not as easily extracted from the code, and there are diagrams that you can make that are not as easily extracted from the code. So you need documentation, but the truth is still in the code. It's not outside. Everything else is a map, it's not the territory. And don't confuse the map with the territory. Our exploration is somewhat ad hoc until we reach a point that our gut tells us that this is the right solution. We try, we run the test again. Software development is very much a craft. And this is a very important part. I think what we are missing, one thing that I keep thinking about and that I keep telling people, every designer, other than software designers, which are programmers, every other designer has to go through a process exploration, and every designer who is serious about the job doesn't stop with the first solution. Never. You always explore possibilities, explore alternatives, and pick one at the end. But often that exploration might involve creating prototypes that showcase that exploration. Too often in software development, we stop based on a gut feeling and we say, that's good enough, it works. Stop here. And the problem with that is you might be missing something. You are most definitely missing something, depending on how much code, how many alternatives you've seen in your work over years of practice. You might miss certain things. If you've seen a lot of things, chances are lower. If you've seen just the same code again, over and over again, then it's very likely you are missing a better alternative or a better fit alternative for your context. If you want to change software development into an engineering practice, then you have to turn those monolithic tools into composable microtools. That is, you have to learn from testing. Tests are small tools and we build our tests to our context. That is the problem we are facing. We should do the same with tools in general. So, very good point. I knew this is where he was going. And this fits with the concept of moldable development. We had Tudor Gârba on this channel talking about moldable development. That's a very interesting idea and one that I'm very much keen to see more people adopt. And it involves creating micro tools fit for your own ecosystem. And tests are a very good example of this. Once you know how to write good tests, you might figure out how to write other kinds of verifications or generation or simulation or all kinds of micro tools that you can imagine. So it's really interesting. Alas, tool vendors are trying to sell us the same tools with an addition of LLMs under the argument that AI is better software development than most people are. Well, in cases that might be true, but it's a craft. We have never turned it into an engineering practice and optimized it. When I've seen groups take software development from a craft to an engineering practice, by abandoning those monolithic tools, even the ones with adding LLMs, then I've seen performance increases of orders of magnitude. Very interesting. Let me read the next paragraph and then comment some more. It's even better when you start to use LLMs to build the contextual tools for the problem you are facing. Hence, I'd like to suggest a different path forward. Rather than rushing to get rid of software engineers, try getting rid of standard tool vendors, even those with added LLMs. and instead focus on toolkits that enable engineers to build the tools they need and turn software development into an engineering practice, like testing. Okay, so let's dive a little bit deeper into this because I think we need to unpack some more. We have all these generic tools, and they provide you all kind of features. Question is, how many of those features do you actually use for your own system? Second question, are there any tools you would like to have that would fit your own system but are not in these tools? And we can take IDEs, for example. IDEs are pretty good. They give us a lot of flexibility. They give us a lot of, they can enhance our development in a number of ways. But the truth is they do not understand and they are not created for our own ecosystem. And that's one of the big challenges with software development. Every software project is different. Particularly the larger it goes, the more separate from other projects it becomes. And so you can go in a few directions. One of them is to standardize the way you structure your software at higher level. And that's kind of what happened with microservices. Microservices are more or less a standardized way, not fully standardized, but we put more and more constraints so that they become more and more standard and so that we can develop them faster and fit them within our infrastructures. But with all their advantages, microservices also have a number of disadvantages. High complexity, operational costs, you need to have a lot of infrastructure. If you are using cloud, maybe you are paying more than you would with other solutions because maybe microservice is not particularly fit for your context. But that's one way. One way is to standardize. The other way would be, how about we ditch the general tools? And okay, we still have an IDE, but it can be something that's simpler, like Visual Studio Code or Vim, and with just the plugin for the technologies that we are using. And then add on top of that micro tools that are specifically built for our ecosystem. And that's another way of supporting our engineering. Right? So I think this is a very, very intriguing idea. Very intriguing idea, and I like it. And one of the nice things about this idea is that large language models are particularly good in small contexts. The more you increase the context, the worse they become. So if you focus on very specific things, it's likely that you can use large language models to help you generate these micro tools. And I really think that part of a development cycle for a team should also be building their own micro tools. Even if you are using them for a month, for 3 months, it's still worth it. And particularly with the speed advance that large language models allow you to, you can build this faster. Moreover, there's no such a big problem with data, right? Because one of the challenges in adopting large language models is, okay, but it will see all our code Do we really want that, particularly in enterprise environments where code is considered to be intellectual property of the organization? And yeah, that code will be exposed. But if instead of working on the code, you work on micro tools that help your engineers develop faster, then that's not such a big problem. Because those micro tools, after all, perhaps some of them can even be open source. If somebody steals one of those micro tools, probably not a big deal, right? It just solves a specific problem for you. Maybe it won't even be useful to other people, right? So I like this idea a lot, and I think this is where we need to go. Basically have an acceleration development path, maybe acceleration teams, maybe in a sprint have 1 day for acceleration, where you implement code, implement micro tools that help you move faster. Imagine how good that would be, particularly with large language models where you can implement these tools much faster. And of course, there's a discussion about IDEs and moldable development. Tudor Gârba plays a link here, post the link here about moldable development. But I like to read another one. Thiago de Faria commented, fascinating as usual. However, I do think that the systems thinking and somewhat rigor needed to do TDD and move toward micro tools or the composable micro tests is not something that the vast majority of nowadays developers know how to do. Unfortunately, that is true. And many people still reject test-driven development without fully understanding how to use it and when to use it. So software has been built with a much lower entry barrier than hands-on craftsmanship, making it something that anyone can pick up and get started. Engineering work implies foundation and a pre-existing knowledge, methods that will gatekeep it. Maybe we should do that for a number of types of software. Airbus comes to mind here. But for the vast majority, it's okay to allow bad code, bad practices to move on and reach production. The rigor wouldn't add much to the business outcome, as the end customer wouldn't care. But it could also mean that it's Sunday afternoon, it has nothing to do with rigor, and I'm speaking nonsense. And Simon answers, unless you build, no, Russell De Pina says, unless you build a tool. Yeah. Interesting comment. Maybe we should start with a specific application. And honestly, I believe that's correct. It's not everything in software development fits every software system. If you are writing just small things, probably you don't need so many practices. If your end customers don't care, if your business doesn't care, I mean, I'm pretty sure they will care about certain quality aspects of your software, like does it do what it's supposed to do? Does it generate a lot of support calls and so on? Are users happy with it? Stuff like that. Do you need the whole process, or is it enough to get a bunch of people and kind of write code? I mean, it works up to a point, right? And if your model is we write a product and then we sell that product and the whole company to somebody else, and it's their problem after that, fine. That's when these micro tools will start being useful. But I think up to a certain size of programs, it's okay to do kind of whatever you can as a programmer, as a team of programmers. But after you reach this size, or if you have specific constraints in terms of non-functional requirements, then you need to step up your work. Anyway, this has been it for me for today. I hope you find that interesting. So what do you think? Do you see some micro tools that you'd like to have for your own products? Um, have you used moldable development? Do you see other options? Let us know in the comments. We love to have comments and chat with you. Thank you kindly for the view, and until next time, remember to think, design, and work smart. See you next Saturday.